This is part 2 of the next series for electrical currents and also voltages. So we will discuss and start on the topic on current. As you can see from here, current is defined as the measure of the amount of electrical charges, or known as your electrons. If you remember, electrons is the game changer in this case. It is basically measuring amount of electrical charges that flows through a circuit. So if you compare these two diagrams over here, what do you notice? You will have noticed that the number of electrons moving across this is actually more compared to the picture on the right hand side. Therefore, we say those with a larger current means you have more electrons, therefore you carry a bit more of your electrical charges. So as you can see, there are many more coming on the left hand side as compared to the right hand side. So if your guess is correct, this current is a large current and this current here is a very small current. Few things that you need to know when you're measuring current. You measure it in amps, or with the symbol A. An ammeter is used to measure the current, as you have seen in this diagram here. You draw a circle and it is in A. And notice that when we attach the ammeter, it is actually in series to that of the component. The picture that you see here is a multimeter. A multimeter is a gadget where you can read your voltage, your resistance, or even your current. And you can even have direct or even AC current, right? DC or AC current, alternative current. Okay? But these are your three main steps. Now this here, if you look very carefully in the notes section, right? If you look very carefully in the notes section, it's actually right on the left hand side. And I have emptied some of the words because you will need to fill in those key points. Alright, and I hope that it makes it easier for you. At the bottom here, right, at the bottom here, it is a diagram for you to draw these two. You can draw the two or you can draw one, so long as the ammeter is attached in series to that of the light bulb. The next one that we are going to talk about would be on voltages. There is a difference between a voltage and also a current. Let's have a look here. A voltage is the measure of the potential difference of how much an energy has been gained or lost by an electric charge. So it's very different from charges just now, which is the current. The current refers to the amount of electrons. Apologies if you cannot see these, right? Amount of electrons that flow through a circuit. Here you're talking about a potential difference. There is a difference between the starting point and the ending point. So have a look at this particular concept. I will come in on Wednesday to explain a little bit more so that you can distinguish between a voltage and also the current. Again, similar to measuring the current, measuring the voltage, you measure it in volts. Similar in terms of the wordings, but it is different because they have specific terminologies, specific terms, specific words. You measure your voltage in volts, V. You use a voltmeter to measure the voltage. And notice where your voltmeter has been positioned. It is parallel. Okay, this section here has a distance. This section here has a distance. So you can know that this here and this here are parallel to each other. Right? This is something that you need to know. It is also in your notes, so don't have to worry. Okay? Again, something that we need to take into consideration. Notice that this is 1.5 volts and this is 4.5 volts. The bigger the difference in energy, the bigger the voltage. So you can be expected that if you have 4 more cells, which makes the battery, that would be 6 volts, it will have a much more voltage as compared to 4.5 or even 1.5. Right? This is something that we will discuss when I come back. But I just want you to know that there is a difference between 1.5 volts and also 4.5 volts here. Okay? I will do this in part 3 because it is now coming to the calculation section.